Hi, welcome to the store. Today we're going to compare noise with various 92mm fans and then look at ways to reduce noise. The setup for this piece is probably going to be about 10 minutes long, so there should be a time signature up or over my shoulder here, and if you go to that you'll be able to see the actual testing now. The tests today are not scientific tests. They're not going to be done in anechoic chambers. Everything's going to be done here in the store on the bench top. The camera will be brought in close, and we'll just use a camera mic to measure noise from about a foot away. And that this will allow you to flip between clips so you can see the relative effects of various fans, different sizes, different speeds, and different noise reduction strategies. All the items you'll see are available in the store. We'll give you their item numbers so you can find them. If you find it, again, if you find this too much information, you'll see a time signature over my shoulder for each product, and that will allow you to move forward in time to see the actual fan. So what we're going to be testing today, Tom, we're going to be testing 3 different fans. First one's a 92 by 15 millimeter fan. Nice little fan designed for kind of a unit that doesn't get a lot of heat, so it just needs a little bit of flow, but it's also very low noise. This is a 34 CFM fan. Very low pressure meaning if you put your hand in front of it, the force you feel of the air coming through, and that is measured in inches of water. That is 0.08 inches of water, so you feel very little pressure. It's also very low noise, 24.3 dBA. My threshold of hearing is about 20 dBA, so it's a little bit above that, so in a quiet room at night you'll hear a very low hum. This is our item 317. The next item would be for more intense heat. It's a 92 by 25 millimeter, what was it, 3.6 inches by 1 inch fan. Years ago, this used to be best you could do would be 50 CFM. Now this one's 79 CFM, so pretty high performance. But not a lot of pressure, 0.15, so it keeps the noise reasonable, about 39.5 dBA, which is a hum, but not a lot of tone noise. It's our item 241 in the store. Compare that with a newer type of fan. This is a 92 by 38, so a little thicker. But as you notice, the impeller, it has an impeller, but on the exhaust side it has what's called stator vanes. So rather than a tube axial fan, this is called a vane axial fan. The vanes, what they do is they straighten the flow out on the exhaust side. So for the same amount of flow you get much higher pressure. In this case, the tube axial fan with 79 CFM gave about 0.15 inches of water. This has almost 3 times as much. It's 0.4 inches of water with a relatively higher flow, 85 CFM. This is our item 314 in the store. So what would you use this for? If you had, again, a lot of heat with a lot of high density components where you had to either exhaust or pressurize the box to get the heat out, this is what you would use. The issue would be in this one, the noise, though it is a little bit higher, it's also tone noise, which means it's certain frequency you'll hear louder noise. In the store we have silent fans available. Silent for me, again, being 21 dBA, so those fans I call silent, or less than that. But we won't be doing that in this video. As a reference point, we're going to run the fan outside of the box. Alright. Okay, this is the 92 by 15 millimeter fan with the self-tapping screws. Okay. Okay, so we now have the unit seated using the isolation mounts. Turn it on. So what we've done is we've mounted our 92 by 15 millimeter fan using an isolation pad between the frame and the fan. Let's turn the fan on. Okay, so we've connected our speed controller, manual speed controller. Let's see if we can power it up. I think that's on full. There's a dial here. Okay, I have that turned all the way back. Okay, I have that turned all the way back. For the next series of tests, we're going to be using our 79 CFM 92 by 25 millimeter fan. Alright, so first let's try the fan outside of the frame. This is a 92 by 25 79 CFM frame with 3 lead wires, and I bring this up just because we get questions about this. Common hookup are black and red, of course, for ground and power, and then this third lead wire is a tack lead wire. It basically goes along for the ride. It's a speed sensor, open collector speed sensor, so if you do not use it, it doesn't impact the fan at all. So here is the fan. Our final series of tests are going to be done with a 92 by 38 millimeter 85 CFM fan. You'll notice that this fan has 11 stator vanes and 7 impeller vanes, or impeller blades. The effect of that is that you have a very high blade passing frequency, and we'll just hook this up freestanding so you can see what that sounds like outside of the box. I think you'll notice a lot of tone noise in that flow. Make sure it's not blocking, that the air is not interfering with the mic. So that's bench top. In our test bed here, pretty much the same. That's at low speed. Well, for our testing, we learned a few things today about fans. Number one, you were able to see how different fans operate, both the standard fans and then the vane axial fans. We learned that the passive treatments have limited effect. The noise isolation mounts will have some effect. The better effect had to do with these pads in getting rid of vibration. It will have an effect for vibration, but not for tone noise. These are not designed to reduce the basic tone noise of fans. For the tone noise of fans, you need some type of speed control to eliminate tone noise, which has a great effect on reducing noise. The downside is that the flow and pressure are reduced significantly. If you reduce fan speed by half, the flow gets cut in half, and the pressure by about 70%. That's it for now. Hope you enjoyed learning as much as we did.